Hey, welcome to this quick setup video for our upcoming tutorial on distributed training of graph neural networks at CODS-COMAD 2024. So we are doing this setup because not every one of you will have a distributed environment on which you can quickly follow the hands-on demo. So we are going to simulate a distributed environment using Docker containers. To get started, first you need the code. So link for the repo is on our tutorial website, so you can clone it from there. So after you have the code, let me quickly explain you what we are going to do. We have this Docker file. So this Docker file, it first pulls a standard Ubuntu 22.04 image and we run it in non-interactive mode to easily install the required software. We are installing Python 3.9 specifically because when we ran our experiments, that was the version we were using. And to ensure the code runs smoothly, we want to keep the environment same. Same is the reason for using these particular versions of Python packages. After that, we set up our SSH server and expose port 22 and initialize the container by running the SSH server so that we can access the container once it starts for our further setup. The next thing is to create a network of Dockers because it's distributed training, so you need multiple containers for multiple nodes, simulating multiple nodes. So we have a bridge network with this subnet mask, and each of them have a IPv4 address through which we can access the container. Next thing is the shared memory. So shared memory is accessible through the /dev/ssm path, and what it happens is this uh, like through the file system we can access this data, but the data is being stored in the RAM instead of the disk. So the reads and writes are going to be faster when it's being stored here, and the DistGL takes advantage of this by storing the distributed graph object on this particular path and thus making the training faster. So to ensure the graph fits, we need to give sufficient amount of memory. So for our small scale example, this is enough, but for larger graphs, you'll need to give more memory or switch the use shared memory option off, and that will slow down your training because now the graph will not be stored in RAM but the disk. The second thing is this volume mount. So we are doing a bind mount. What this does is that whatever changes take place in this host folder, that is your PC's folder, this will reflect in the real time in the running container at this path. So and what we do is share the same folder with all the containers. So we have kind of created a shared file system in these 4 containers to access common data which is needed during the distributed training. In an actual distributed environment, you would have used something like a network file system NFS with NFS server and clients, but here for simplicity we are using this bind mount. Then one important note is that you should update the path over here. So wherever you cloned the repo on your PC, that path you have to update here and use an absolute path to avoid any confusion. So if that is clear, we can start the setup. So what I'll do is run sudo docker compose up to build the images. I'm running it with sudo because the Docker is installed on sudo for the sudo user, but depending on how you installed it, you might not need to do that. This step will run quickly for me because I built the images previously, so the steps were cached, but for you it might take some time for the first run. Once that is done, we will up our containers with this command. So the 4 containers have been created, and just to verify, I'll run. So these 4 R containers have been created. So I'll SSH into one of them. For me, it's going to be container 1, and we'll do the further setup, which is enabling passwordless SSH for our training. So what happens is that on this we'll be using this particular container to launch our training command. So what the training command does is it SSH into each of the training nodes and starts the training processes on those nodes. So for that we need the passwordless SSH. And how we'll achieve it is by using a private and public key. So we'll create a private public key pair on this container one, and we'll add the public key to the authorized keys in each of the containers so that it can SSH directly with that. And you should note that you need to do that for container one as well. So you need to add the public key to container one's authorized keys as well, so that container one can SSH into itself without a password, because this does not work by default. So to do that, we already have steps here in the SSH key setup. So you can just copy the command, this one. So this you will just run once on container one to create your private public key pair. So it's generating the key, and it has generated the key at this path. So I will quickly cat it and copy the public key and paste it over here. So that just prepares a script. So what we need to do is now just paste it at the relevant folder, and to automate that I have written this small script, so you don't need to run these set of commands on each of the containers one by one. You can just run the script. Just to ensure that it has execution permissions, I'm going to do chmod +x ssh. Okay, I shall just change it to the folder. So I'll go to EAT. Yeah, I'm here, so I'll do chmod +x ssh. Yep. So I've done that. So now I can just run the script. Yeah, it has run. And just to ensure that everything has been done correctly, we'll just try to SSH it into container one itself. For that, I'll just copy the IP of container one from here. You can also use the alias container one, but let's use the IP for the sake of this demo. So for the first time you'll have to type yes, but after this, you whenever it SSHs, it directly does the job without this yes. So it's working, so that's done. Now let's do it for each of the containers. So I go to container 2, switch to EAT, and then run SSH. Okay, done. Let's go to container 3. Let's go to container 4. So this you need to do a bit manually. You could maybe automate it, but yeah, will not take much time. So just quickly doing it. Yeah, so this is done. So just to verify, we'll go into container 1 and try to SSH into all of them one by one. So yeah, put a yes, it's working. Exit. Yes, yes, exit, and finally 5. Yes, exit. So yeah, what we have done is done passwordless SSH. So now container 1 can directly SSH into each of the 4 containers and run the training command. And with this, the setup is done. You are all set to run the distributed training on this simulated container environment. And once you are done with running the code, just to bring down the environment, what you can do is run sudo docker compose down. So once you run this command, it will bring down all the containers and delete the network, so that you have your computer back again. So that's it. Hope you find it useful.